Hi guys, welcome back. Today we're going to be starting a basic introduction to Algebra 2, and we're just going to be learning about different kinds of numbers and how to classify them. So the official name of what we're going to be doing today is classification of numbers. And what classification of numbers are, basically, I have to explain this. Okay, numbers can be classified into a lot of different groups. Some examples are real numbers, complex numbers, whole numbers, natural numbers, and etc. So each classification is based on the characteristics or properties that these numbers have. So first, let's talk about what type of these numbers, complex numbers. So complex numbers are the broadest category, so they're like, if this is where they are, there's a bunch of different ones branching out from it. So it has a lot of different categories, but to be quite frank, it's just the broadest one. Complex numbers include both real numbers and imaginary numbers. And we'll get into what those are later. But imaginary, we'll just get into what real numbers are. Imaginary numbers are something we'll deal with later in Algebra 2. So, in real numbers, we have, the definition is quite simple. Real numbers are just any number that is not imaginary. So real numbers are literally just anything that's not imaginary. So any number that exists, that you write down, that can exist. Now, like complex numbers, real numbers is also quite broad. So let me just clear this up. So real numbers are also very broad. So in real numbers, we have something called rational numbers. Now, what rational numbers, to be quite frank, they're just numbers that make sense, and that's what rational means. So numbers that are numbers that can be, or another direct definition is any number that can be written as a ratio of two integers. So, and then it also can be repeating or terminating decimals. So some examples of this would be 2/3. That's a number that makes sense. Another number, 0.666 repeating. That is also a rational number. Another example, 1/4. That is a number that is rational. It can be written as as a proportion or a ratio of 2. What I mean when I say a ratio of 2 is that there's two numbers. It's a fraction or a decimal. So it has 2/3. That's a ratio. This one, if you were to put it into a fraction form, that would be 2/3. That's 2/3 ratio. 1/4 ratio. Another example of this would be 0.25, which is 1/4, which is a rational number. So now we've learned about what rational numbers are. So what's the other kind? Well, they're called irrational numbers. Let's just clear this up again. Irrational numbers. Now to be really direct, irrational numbers are just numbers that are not rational. So they cannot be written as a ratio of 2. So not ratio of 2. Integers, my bad. And they are non-repeating decimals, so they cannot be repeating, and it can be like 0.666 like we looked at before. So some examples, let me just change the color real quick. Some examples of this would be, let's say, the square root of 3. There is no square root of 3. That is rational. So that would be an irrational number. Another example of this would be pi, which is 3.1415, and it's going on forever. So it's not repeating. It doesn't repeat a pattern. So that makes it irrational. Another example of this is E, which I believe is Euler's number. I'm not quite sure what the actual number is. I just know that it doesn't repeat. Okay, so let's move on to some more subcategories. So let's clean this up for a second. Let's talk about whole numbers / integers. Almost ran out of space there. Now, whole numbers are just simply whole numbers. They are just numbers like 2, 3, 4, and they're like integers, so they can be -2, -3, -4. So they're the numbers that we work with the most, and they're numbers that are usually coefficients, and yeah, they're just the numbers you see very often. I can't really describe this that well because they're just so, it's kind of common sense a little bit. Okay, so, and another important thing to note is that they include, okay, let me just change the color so I can see. They include 0. This is very important because we're going to be learning about natural numbers next. So, on that note, let's move on to natural numbers. Okay, natural numbers are numbers that are like 1, 2, 3, 4, and so on and so forth, except they exclude 0. So, unlike the whole numbers and integers, which included 0, natural numbers exclude 0, which is really important when you're classifying these numbers. But everything else is about the same. Okay, so now that we have learned about how to classify all these numbers, let's put it in practice. So let's do some examples. Let's do number 1, number 2, number 3, number 4. Okay. Let's do 2/5. Pi/2. Square root of 2. And 0. Okay, so let's classify these together. Okay, so sorry, a little bit of malfunction there. Okay, so 2/5. So 2/5, that's a ratio of 2 integers, so we know that that is a rational number. So we can go ahead and write rational. And since we know it's rational, then the bigger umbrella of rational is real. So we can write it is also real. Now since it is rational, it can't be irrational. And since it's a fraction, it can't be a whole number. And since it is also a fraction, it can't be a natural number either. Okay, so we're done with that one. Let's move on to pi/2. Now pi/2 is a ratio of 2 integers. Or my bad. Yeah, no, I'm sorry. It is a ratio of 2 integers, which means it's a rational number. Now, as we said before, because it is rational, it's also a real number. And since it's rational, it can't be an irrational number. And since it's a fraction, it can't be a whole number either, which makes it not natural either. Okay, let's go over the square root of 2. Now, okay, so this one is not a ratio of two integers, which means it's not rational. But it can still be irrational, or a real number. So let's look at the square root of 2. So the square root of 2 is a number that is not a fraction, so that means it's irrational. And that makes it real as well, because it's the bigger umbrella. And the square root of 2 is not a whole number, and which makes it not a natural number either. Okay, 0. Now this is why it was important to pay attention earlier. So, as I said before, natural numbers do not include 0, which makes this not a natural number. And since it's not a natural number, it's not a whole number either. Now, this can be written as a fraction, as 0 over 1, 0 over 2, anything like this. So, this is a rational number, which makes it also a real number as well. Okay, let's go over 2 more examples before we end for today. Change the color. Okay, so let's do 5 and 6. Let's do the square root of 25 and -1 over 3. Okay, so the square root of 25, if we look it up, is 5. So essentially what the number we're looking at is 5. So we know that 5 is a whole number. It can be written as a fraction, as 25 over 5. So that is also a rational number, which means it's also a real number. And it's not irrational, so you can get rid of that. And it is also a natural number, because of the umbrella of a whole number. Okay, and it's not 0 either, which makes it also a natural number. Okay, now our last question for today. -1/3. Now, what I didn't mention earlier about real numbers or natural numbers is that they are all positive. Natural numbers are all positive. So this number is clearly negative, so we know it is not a natural number. So it's not a natural number. Just got the NAT. And it is not a whole number either, because it's also negative. And it is a fraction, as you can see. It's a ratio of 2 integers, which means it's a rational number. And it can't be irrational because of it being rational. And since it's rational, it has to be a real number as well. So this number, -1/3, is a rational number and is a real number, and is not irrational, not natural, and not whole. Okay. So that concludes our lesson for today. Thank you so much for watching. I forgot to announce that I have way better audiovisual software. I found some. It works so much better. The camera quality is better. It's awesome. So, thanks guys for watching. Don't forget to like and subscribe below. And I'll see you in the next video. Bye.